It's a pleasure to be here. I want to introduce myself, telling you what I've done the last years. My motivation basically is that the classroom hasn't changed in the last 100 years. And in 1996, I asked myself how we could really change the classroom. And we started using the Game Boy of Nintendo. And the idea was to bring really games inside the classroom. And we really managed it. The kids really had fun. The kids learned more. I have a publication, Computers Education, 2003, if you're interested. And we really get interesting results. However, what we did is we didn't really change the classroom. We just brought computers inside the classroom. Yeah? And the idea is to have a different classroom, a 21st century classroom. So we used in 2001 the power of pocket PCs with wireless networks and brought collaboration inside the classroom. Is it loud enough? Can you hear me? So we really break the classroom, doing small group collaboration. And the basic idea was to have students that were interdependent, students that really worked together, synchronized, collaborate. And here we really achieved amazing results, really very interesting results. We are today in almost 100 schools in 5 countries, working with small group collaboration. And the idea here was not only to work with pocket PCs, because technology, the pedagogy is not dependent on technology, so we work not only with pocket PCs, we worked also with classmates, that is netbooks, and phones. The problem of phones is that we use the Wi-Fi network because the Bluetooth network is not reliable enough, not fast enough. So the only problem there is that we don't have a good network to use phones. However, we could do the same stuff on phones, which we did, but with Wi-Fi networks. And the latest move was to use a Microsoft SDK of multi-mouse, where 3 kids work collaboratively on one screen and also working in small groups, but with one machine, which is very attractive for underdeveloped countries. We are now working in Chile and Guatemala with this. And this is really very interesting. And the latest move is to have massive multiple mice. That means that have up to 50 kids working with one machine, in this case one projector, and instead of one computer per child is one mouse per child, which is very, very cheap if you think in undeveloped countries. And this worked really very nice. So our question was now, can we go further? Not only do creative work, but can we really do games inside the classroom and go back to our roots in the late 90s when we worked with games? And here comes the Games for Learning Institute. And what we want to do basically here are 2 things. First, we want to use the design guidelines of the Games for Learning Institute, use them, validate them, but also integrate our collaboration knowledge, because I am convinced that games are really collaborative. Games are not one-to-one. Games are really about a lot of kids working together. In that sense, what we want to do is go far beyond 3 kids. We want to integrate the whole classroom. And we're looking in things like World of Warcraft. World of Warcraft is more than 50 kids. World of Warcraft is 50,000 kids and much more. And the point is, why is it so popular? Can we bring this type of game inside the classroom? And if you look to this, World of Warcraft is a massive multiplayer online game. And what we want to do is, instead of being massive, we just want to bring it inside the classroom. And instead of online, we want to be presential, the same place. So instead of MMOG, we're talking about CMPGs. And that's what we want to develop now. Additionally, the point of things like World of Warcraft is that there's still a screen there. We all look facing a screen. And with one of my PhD students, which is here, we are working on augmented reality, which I think is fascinating. Because what happens here is that you're not looking anymore at a screen, you're working in the whole classroom. You're looking, facing the whole classroom, and the whole classroom is the virtual world. So what we want to do is, and the first thing we're going to do is to teach physics, and within physics, our first experience we want to do here is to teach electric charges. And what we want to do is an experience like this one. The first thing is children have to find out if their peers have the same charge or different charge like them. And they will all have a mark here on the screen, in the face or in these faces, so that the machine knows who they are. And they will find out if the peer has the same or different charge by looking to the machine, and if the peer zooms in or zooms out, means it has the same or different charge, because they attract or reject. Afterwards, they know the different peers, what type of charge they have. They will look to the classroom, and they will see that inside the classroom it's full of asteroids. And in one corner of the classroom, there is a space shuttle, and the space shuttle has to land. So for this, they have to move the different asteroids. So the asteroids can only be moved through their electric charges, and they have to move them in small groups, which are randomly formed. So they have to move inside the classroom in this virtual world, which can only be seen with this augmented reality, and working really in an immersive space. So we want to use this type of application not only with this virtual augmented reality, but also with 4 screens in the classroom, and compare what you gain and lose with these two types of technology. And of course, using the guidelines of the Institute to validate them and to really get a better outcome and to really understand what is a good game.